This is an introduction to a grad course on axiomatic design and manufacturing processes. I am Chris Brown, a professor in the Mechanical Engineering Department at WPI. This introduces two grad classes that have got similar content. They're both dealing with axiomatic design and applications in manufacturing, in particular manufacturing processes. One of these is offered online only for 2 credits, and that we'll call Elements of Axiomatic Design of Manufacturing Processes. That will be offered 4 times a year, 7 weeks. It's a 7-week course, and in the summer. The other is on campus. That'll be a 14-week class, and the in-class periods will be used for discussion and in-class exercises, justifying the extra credit. That will be offered in the fall term only. Or the fall semester only, going for 2 terms. Enrollment in both of these is limited to ensure quality. You can only get credit for one of these, not both, but if you'd like to do more work on axiomatic design, you can always do an independent study project, those would preferably be done in the summer, but could be arranged at different times. AD, Axiomatic Design of Manufacturing Processes. The course has been known also as Design and Analysis of Manufacturing Processes. When I came here about 25 years ago, it was just called Analysis of Manufacturing Processes. But design is the thing that engineers do, and I changed the title to emphasize the design. Students have often referred to it just as axiomatic design because of the emphasis that I've placed on that. It's been developed over 25 years. The course has both full-time graduate students and part-time students who are working in industry. So that's always made for good discussions, and I'm grateful to the students for helping me with the development of the class and all of the interesting discussions that have led to the content that I've developed over the last 25 years. One of the objectives I had with so many working engineers in the class was to provide them with something that they could use at work in their jobs during the course. The course is specifically not intended to be a kind of rite of passage exercise in math, which some graduate courses seem to be. The course is intended for engineers, manufacturing managers, engineering students, and it could be engineers of all types. It's a graduate level class, but it is certainly within the reach of many undergraduates. There's no prior knowledge required for axiomatic design or for manufacturing. The approach that I'm taking to both of these is special and original. AD, Axiomatic Design. This is a special approach to engineering design. And it's valuable to anybody who does any kind of design work and any kind of planning. It doesn't matter what you're designing. Could be orbital space planes or could be vacations. We can use it either quantitatively or qualitatively, and we'll be looking at both of these as we develop the class. Axiomatic design is based on 2 axioms that are fundamental to all good designs and can be used to develop the best design solutions. One is maintain the independence of the functional requirements. This makes sure that the design is adjustable and controllable. And the other is to minimize the information content of the design. And this assures that the design will be robust. And of course there'll be much more on these later. The objective of the course is to help students become better engineers And they can do this by learning how to create and develop the best design solutions. Also, I want students to learn how to apply the information that's in the technical literature to design problems. The technical articles are written often at great cost and with great effort, and repeating the work that's done to get the information that's in the articles can be expensive, and it's all there for you to use. So being able to find what you need in the technical literature and interpret it so that it can solve you can use it to solve design problems is a big asset. Typically the cost of writing one of these articles and preparing all the stuff is in the tens to hundreds of thousands of dollars. And the information is available. All right, the other thing is to understand manufacturing processes, particularly in the context of axiomatic design. So let's take a look at all this. So here's what we call a design matrix. Now the FRs are the functional requirements, and those are listed down the left side, and that's what we would like to be able to do, and essentially that's the three things that we just talked about. Then the DPs are the design parameters, or the design solutions essentially, that are used to fulfill the FRs. And the X's in the matrix show where there are interactions. So what we are able to see by this matrix is that the course needs to address axiomatic design before manufacturing processes, and hence that will be in the order of the lectures. In fact, what we'll do is we will take the axiomatic design and make that so that it can be used separately, all by itself, and will be packaged separately. But the manufacturing process component of this will only make sense if you understand axiomatic design. The part on finding information in the technical literature will be loosely linked to axiomatic design, because we will be looking for certain kinds of information that will be used to support the activities in axiomatic design, but will be valuable by itself as well. So more on this, of course, will follow in the course. The course content will be primarily provided on video books, which are available from retrieve.com. Now, the video books have got indexes and text on them, so they're much more valuable than normal video lectures, because you can go to the section, using the index, you can go to the section of the video where certain things are addressed. Both WPI courses are going to be served by these video book lectures. As I said, the content is going to be the same for both courses, and the content that I'm talking about here is lectures, reading, quizzes, assignments, and a final project. So the approach for the course. So as I said, the content's provided by these video lectures. They'll be in modules that are intended to be about 15 to 20 minutes long. The video books are for purchase. There'll be other video materials as well as readings. They'll be supplied, and those will be on the course website and often mentioned in the video book lectures. And then for the verification of understanding, there'll be quizzes online, multiple choice. The answers will be given when you complete the quiz. And the idea is that the quiz is a learning exercise and as much a verification for you of your understanding and what you need to review as it is for providing some assessment for me. The assignments are essentially practice and lead to the project. So the assignments will be there to help you do a better final project. Now the project is the main sort of practice, and that you will be creating and developing a solution to a problem, a design problem in manufacturing processes. And for that you're going to be using axiomatic design and information from the technical literature. So the grades will be based on the performance, the quizzes, the assignments, and the final project. The due dates are suggested. No points are deducted for late submission. Obviously, if you have to go over the end of the class, then I will have to give you an incomplete until you're able to complete it. But it's a grad class. I know people have other obligations at work and with their families, so the dates are just suggested. Nonetheless, the work should be done in order. There's a certain logical sequence for the pedagogy, and assignments that receive a grade of below 7 out of 10 should be redone so that we can use these appropriately to support work on the final project. So if you get less than a 7 out of 10, I'd like you to resubmit and see if you can improve that for work on the final project. The idea is that I would like to support your project work so that everybody can do well on their final project. So in the projects and the assignments, the idea is to integrate axiomatic design, analysis of manufacturing processes, and the information from the technical literature. So the assignments, like the quizzes, will be posted on the course website. And as I mentioned, the assignments are going to support the final project work. Students should keep a portfolio of all their work for the course. And this must be submitted with any request for reconsideration of the final grade. Discussion on grades during the class should be limited. It's much better to wait and see what the final grade is, and then make adjustments from there if needed. So axiomatic design is going to be developed in steps, and the idea is to, in the first 8 lectures, is to get you to, or first 8 modules, is to get to a novice level for quantitative use, and then bring you up to a level where you can do quantitative use. So first qualitative, then quantitative, and then a third level, giving you a foundation for lifelong learning and the ability to address some of the advanced issues and take advantage of articles from the technical literature. So the idea is that you learn how to develop the best solutions to design problems using axiomatic design, understand the analysis of manufacturing processes to support the design, and be able to get useful information from the technical literature. So before ending the introduction, let me say a few words about myself. I went to the University of Vermont, got all 3 degrees there. My bachelor's degree was in liberal arts, and I spent most of my time ski racing. I later coached skiing, and I still do. My master's degree, though, was in mechanical engineering and working on a materials problem and developing a test for measuring the dynamic fracture energy of tools. And my doctorate was on material behavior during chip formation and machining. And I did the master's and doctorate with Professor Branimir von Turkovich. After finishing my doctorate, I was fortunate to be able to go to the Swiss Federal Institute of Technology in Lausanne, where I stayed for nearly 5 years in the materials department, working in mechanical metallurgy, and I formed the mechanical surface treatment group there. After finishing at EPFL, at the Swiss Federal Institute of Technology in Lausanne, I went to work at Atlas Copco's European Research Center for nearly 2 years, and worked there on coatings and surfaces primarily. Atlas Copco makes air tools and air compressors, and at that time had a research center in Switzerland. Since 1989, the fall of 1989, I've been at WPI in the mechanical engineering department. And here I founded and still direct WPI's surface metrology lab. Surface metrology is the measurement and analysis of surface textures or surface topographies, and it deals with problems in surface roughness, how surface roughness is created or manufactured, and how it influences the behavior of parts or surfaces, things like adhesion, friction, and scattering. I also founded WPI's Haas Technical Education Center for CNC machining. I am no longer directly involved with that, but it is a successful center here at WPI with over 11 CNC machine tools, and was made possible by the generosity of Haas Automation, in addition to support from many other companies, including DP Technologies, who has provided us with Esprit for use there. Anyway, thank you very much for your attention, and we will, the following lectures then will deal with axiomatic design.